Okay, folks, today we're going to, in our podcast, look at some theorems, and we're going to do a little bit of proof. We're going to back off it a little bit for today. We're going to go more for it tomorrow. We're looking more at the algebra end of things today, again, and applying things to algebra. So a little bit of a break. There will be one proof in the notes today, but not too bad. So hopefully you'll find this a little bit of a welcome rest from the proof idea. Let your brains get a little time to recover. All right, so a couple new theorems. Right angle congruence theorems. All right angles are congruent. Now, this is one that really almost goes without saying. I mean, really, all right angles are congruent? Well, what does the measure have to be of a right angle? 90 degrees, right? And every right angle has to be 90 degrees, right? Right. And if any two angles have the same measurement, they're congruent. Right. So all right angles would have to be congruent to all other right angles. Yeah. Essentially what's going on. Let's prove it formally. Angle 1 and angle 2 are right angles. Prove angle 1 is congruent to angle 2. We just talked through it. We just reasoned through it. Now we're going to write it down as a logical argument. I told you there'd be one proof. In today's lecture, this is it. So let's see how this would work. Step 1. Angle 1, sorry, I was going to write given right away. That goes on the other side. Angle 1 and angle 2 are right angles. Given. Now, when we just talked through it, what did we say? Go back and listen if you want to. You can go back, rewind, and listen to what we just said. Oh, what does it mean that they're right angles? What does it mean that two things are right angles? Again, we have a vocabulary term here, don't we? Right angles. What does that mean? Well, it means they measure 90. So the measure of angle 1 equals 90 degrees, and the measure of angle 2 equals 90 degrees. That's the definition of right angle. Well, if I have two things equal to the same value, if m angle 1 equals 90 and m angle 2 equals 90, they both equal 90, so they must be equal to each other. That's substitution. Substitution gets used a lot. Substituting in one value for another equivalent value. We do that a lot. All right, and if two things have equal measure, what does that mean? Oh, equal measure, another way of saying equal measure is congruence. And the reason is definition of congruence. Remember we said yesterday, anytime we go from equal measure to congruence or congruence to equal measure, whenever we make that change from one to the other, that's using the definition of congruence. We'll do that a lot. And what is it we're trying to prove? We're trying to prove that angle 1 is congruent to angle 2. That's what we did. We're done. Very important to note, I use given as a reason right here. Never, ever, under any circumstance, will you use the word prove in your reason column over here. It will never appear, ever. If you do it, guaranteed wrong. You might as well write in there, if you're going to write prove ever over here, you might as well just write in there, please take points off my test. Please assume that I do not know what I'm talking about, because I'm writing something over here that never is going to work. Ever. Prove is never a reason. Without exceptions. Prove is never a reason. So never, given is a reason, prove never goes over there. Please, please. If you learn one thing today, make that it. All right. Congruent supplements theorem. This is kind of fun. If two angles are supplementary to the same angle, or congruent angles, they are congruent. Now, wait a minute. So if angle 1 and angle 2 are supplementary, and angle 3 and angle 2 are supplementary, then angle 1 and angle 3 are congruent. This kind of defies our transitive property. Wait a minute, if 1 is congruent to 2 and 2 is congruent to 3, then 1 is congruent to 3. That's transitive property, yep. If 1 is supplementary to 2 and 2 is supplementary to 3, then 1 is congruent to 3? Yeah. The property of being supplementary is not transitive. The property of being supplementary or complementary is not transitive. Equality is transitive. Congruence is transitive. Supplementary and complementary are not transitive. And it makes sense when you think about it. Look at the picture. Angle 1 and angle 2 add up to 180. Angle 2 and angle 3 add up to 180. Angle 1 and angle 3 clearly are not going to add up to 180, are they? Clearly not. Now, could there be a situation where they do? Well, sure. If they're all right angles, it would actually work. But that's not normally the case. Angle 1 and angle 3, because they're both supplementary to angle 2, have to be congruent. Same with complementary. Same thing happens here. Angle 4 and angle 5 are complementary. Angle 5 and angle 6 are complementary. Now, a little less obvious here, but angle 4 must be congruent to angle 6. Just from the picture, it's a little less obvious. But again, if we put numbers in here, let's say, for example, just for fun, let's say this angle was 40 degrees. Then this angle would have to be 50 degrees in order for them to be complementary. If these two are complementary, 5 and 6 now, what does the measure of 6 have to be? 40 degrees. Oh, congruent to number 4, not complementary to number 4. And you can put whatever numbers you want in there. It always works out. Two other interesting theorems we're going to work with. The linear pair postulate, we've already done this. You already know this, that a linear pair is supplementary. They add up to 180 degrees. We've already worked with that one. The other one is the vertical angles theorem. This one we haven't worked with, but it's one that you probably have noticed already. That if we have vertical pairs of angles, those vertical pairs are congruent. And again, the proof is on page 108. It's fairly obvious. I can run you through it pretty quickly. Not in full 2-column format, but if this angle is x, then this angle has to be 180 minus x. Because they're linear pairs. They have to add up to 180. If this area is 180 minus x, and this is 180 minus 180 minus x, 180 minus 180 is 0. Negative negative x means that this angle is just x. Oh, they have to be congruent. And then this 80 is also 180 minus x. Oh, they're congruent also. Vertical angles are congruent. That's essentially the proof. Now, a lot of our homework today is actually going to deal with just applying these things. For example, here we're going to apply the vertical angles theorem because we have vertical angles. 3x plus 1 and 4 and 48. Now, stop and think. I've talked about this a lot. It's all about relationship. What is the relationship between those two angles? What is the name of that angle pair? And then what does that mean? Are they adding up to 180? Are they congruent? Are they complementary? Do they add up to 90? Do they add up to some other sum? Determine the relationship before you set up your equation. Don't just dive into, oh, I'm going to add them up to 180, or I'm going to set them equal to each other. If you do that, you're going to be wrong 3 out of 4 times. So stop and think. I have vertical angles. Vertical angles are congruent. Now, there's a little logic involved here too. 148 is obviously a very obtuse angle. So is the 3x plus 1. They're both really obviously obtuse angles. Even if I can't remember the name or the relationship, at least I should be able to look at the picture and say, wow, they clearly aren't going to add up to 180 because they're both over 90 to start with. And they aren't going to add up to 90. It looks like they're about the same measure. Let's go with that. And without having to prove it here, we just do our algebra. 147, sorry, 14x. 147. And 147 divided by 3, 150 divided by 3 is 50, so it must be 49. Is that the answer they wanted us to get? Am I done? Yes. Find the value of x is what the question was asking. I'm good. I don't have to substitute that back in anywhere. Use this to find the other angles around the, use the vertical angles theorem and the linear pair postulate. So if M angle 1 is 117, now these are separate problems, so each one we're redoing the whole picture here. That can be a little confusing sometimes. Some people say, oh, 1 is 117, 2 is 59, 4 is 88. Wait a minute, 2 and 4 have to be congruent. That has to be wrong. No, they're different problems, okay? So don't worry about that. We're going to find M angle 2, M angle 3, and M angle 4 in this situation, and then we're going to reset and do it again. So if 1 is 117, which other one has to be 117? The vertical one has to be. The other two have to be supplementary because they're linear pairs, which means adding up to 180. So 117 plus what is 180? That would be 63. Let's reset. Here's M angle 2. This time we need angle 1, angle 3, and M angle 4. Angle 2 is going to be the same as angle 4, so that's 59. I should get my degree symbol in there because we're doing angle measures. This is going to add 180, so that would be 121 for the other two angles. And I think you get the idea pretty quickly. For this one, M angle 4 is 88. So again, we're resetting. I'll switch colors. 4 and 2 go together, so I'll do that next. M angle 2 is also 88 degrees. And M angle 1 is 92 degrees. M angle 3 is also 92 degrees. So we have all of our angle measurements. You'll be seeing problems like that. Not really very difficult. Again, find the value of W, look at the picture, determine what's going on. Be careful. This is one of those problems where you could look at this and say, oh, it's a right angle, because it looks like it's pretty close to a right angle if you're not paying attention. But it's not. There's nothing to indicate that would be a false conclusion if you said it's a right angle. But 5W plus 3 does have to equal 98. And again, pretty simple to solve once we get it set up. Is that the answer we're looking for? What are we looking for? We want to find the value of W. We found the value of W. Always checking to make sure we're answering the question that's being asked. Here we're looking for X and Y. You have to be a little bit careful here because this could change, these problems could change depending on how things are set up. In this case, we want to put the x's together and their vertical angles. So I'm going to say 2x plus 15 equals 3x minus 5. And again, relatively easy to solve. I get x equals 20. For the y's, again, they're vertical angles across from each other. So 5y equals y plus 100. And subtract the y from each side. I get y. 4y equals 100, so y is 25. And I've got my solutions. But I could give you the exact same picture and do a little bit of a changing around here. And we're going to get completely different equations, aren't we? Because now I have a situation where we have linear pairs. The x's are a linear pair. Not. I'm going to do a different color so we can justify that. The x's are a linear pair. They are no longer vertical angles. They aren't congruent anymore. So for this particular situation, I need to go 2x plus 15 plus 3x minus 5 equals 180. Combining terms, I get 5x plus 10 equals 180. So 5x equals 170. So x equals, what is that, 34? And do the same thing with the y's. Here my y equation would be 5y plus 100 equals 180. So 6y plus 100 equals 180. So 6y equals 80. So y equals 80 divided by 6, which is 40 over 3, which doesn't come out to a really nice number, but we could leave it at 40 over 3. 40 thirds, 13 1/3. That's okay. So depending on, notice we had the exact same values, but depending on how they were arranged, my equations and my solutions were completely different. So when I rearranged the equations, I came up with different situations. That's why it's so important, so very important, like we've been talking about for a long time. Look at the picture, establish the relationship. It's all about relationships. I've been saying that for 2 weeks now. Before you start to set things up, don't just slap things equal to each other. Don't just add them up to 180. You got to decide what's going on in the picture before you make your decision and set up your equation. That's really important. And this is a great example of how just flipping two values, two little algebra expressions around on the diagram gave us completely different situations. It would be easy to have one of each problem sitting right next to each other in the homework or somewhere else. Finally, one last statement. If angle A is supplementary to angle B and angle B is supplementary to angle C, then angle A is congruent to angle C. Remembering that's the congruent supplements theorem. Just a reminder, if you're not sure, draw that picture. Angle A is supplementary to angle B. Angle B is supplementary to angle C. Angle A and C are not supplementary. Angle A and C are congruent. You get the idea. That's our notes for today. I'll see you in class.